Here is our problem. In this problem, there is a climber who wants to climb a smooth frictionless conical mountain by using a lasso, which is thrown over its peak. The rope of the lasso lies along the surface of the cone. We are assuming that the climber is a point mass and the rope is light, that is massless. He has two options of using a lasso. The first is cheap lasso, that is fixed loop, and the second is deluxe lasso, that is flexible loop. When the mountain is viewed from the side, it has an angle alpha at its peak. Now, for what angle alpha can the climber climb up the mountain by using option A, the cheap lasso, and option B, the deluxe lasso? At first, we take the case of cheap lasso, where the length of the loop is fixed. For solving this problem, our first step is to unwrap the cone vertically through the point C, that is through the knot. This is shown in figure 1 and figure 2. Figure 2 is the unwrapped condition of figure 1. Now from figure 2, we can see that C, C' are the same points, and also there is a tension in the rope. So we can say that C, C' must be horizontal and straight. Now also from figure 2, we can say that angle beta must be less than pi. Since if beta is equal to pi, the loop cannot hold the surface. This can be shown in figure 3. So beta is less than pi. This is our equation 1. Now also from figure 2, that C, C', this is the length of the rope of the loop, must be equal to beta into d. Here d is the slant height from the peak point A to the rope. Also from figure 1, the total length of the rope of the loop must be equal to the circumference of the loop, and this is equal to 2 pi into d into sine alpha by 2, where d into sine alpha by 2 is the radius of the loop. This can be shown in figure 1. Now from the geometry of figure 1 and figure 2, we can say that 2 pi into d into sine alpha by 2 must be equal to beta into d. That is, beta is equal to 2 pi into sine alpha by 2. This is our equation 2. Now from equation 1 and 2, we can say that 2 pi into sine alpha by 2 is less than pi. That is, sine alpha by 2 is less than 1 by 2. It means alpha is less than pi by 3. This is the answer of the first part of our problem. Here is the case of deluxe lasso, where the loop length is flexible. This is the explanation 1, that is force method. Here again, we unwrap the cone. Since the loop length is flexible, so it adjusts itself with tension, and at the equilibrium position, as it is clear from figures that at the knock point C, the tensions in all the three segments are equal. That is, T1 is equal to T2 is equal to T3. This is equal to T. And each pair of segments makes an angle of 120 degree. Again, from figure 2, the line CC' must be straight so that it could maintain the tension in the loop, and also horizontal, as C and C' are the same point. Again in figure 2, in triangle CAC', we see that angle ACC' must be equal to the angle AC' C, and this is equal to 60 degree, so that the angle CAC' is equal to 60 degree. That is, beta is equal to 60 degree. This is our equation 1. And from the geometry of figure 1 and 2, we can see that 2 pi into d into sine alpha by 2 is equal to bc, and this must be equal to c prime. This is equal to beta into d. That is, from equation 1 we can say that pi into sine alpha by 2 is equal to pi by 3 into 1 by 2. That is, sine alpha by 2 is equal to 1 by 6. And it means alpha is approximately equal to 19 degree. This is the answer of our part 2. Here is our second explanation, that is energy method. We know that in case of climbing the mountain, the potential energy should not decrease. Actually, it should increase. Since here the loop is flexible, so the length of the loop adjusts itself. And in this case, there may be two conditions. Condition 1, if the loop length decreases, it means extra length of the rope go downward, so the climber. It means there is a decrease in potential energy. Now, this is condition number 2. Here the loop length increases. In this case, the loop itself goes downward and also the climber. So in this case also, that there is a decrease in potential energy. So in order to avoid this, there must be only one condition, that the change in loop length must be equal to the change in slant height of the loop from the peak. Now, in the equilibrium condition, it is only possible when the triangle CAC prime is an equilateral triangle. That is, beta is equal to 60 degree. So here again, we can get the answer by just proceeding with the same steps as given in the explanation 1, and we will get the answer.